Okay, more 30 seconds. When it comes after 1 minute, when I start, no, then there is no mismatching. Okay. If I go before that, no, there is mismatching of voice and action I have observed. Okay, let's start. So, quadratic equation, okay? In that we saw that the standard format of the quadratic equation is what is the standard format? And the standard format means what is the form of the quadratic equation? General form, standard form. This So this is the standard form, this is the general form. Ax square plus bx plus c is equal to 0. In this, a polynomial equated to 0 is called equation, polynomial equation. And since the degree is 2, it is called a quadratic equation. Okay. So for the quadratic equation, for any equation to be called as quadratic, the degree must be 2. No, degree must be 2. It can even be like this: ax square is equal to plus c is equal to 0. Then also it is a quadratic equation or not? Yes. And this one? Or quadratic or something k quadratic. Okay. So quadratic only because the degree is 2. So this is the standard form. Okay. These are also the forms, but these are not the standard ones. The standard means the coefficient of x will be available, the constant will be available, everything. Okay. So see exercise 4.1. Exercise 4.1, the first question. What is it? What is it? Check whether the following are quadratic equations. No. So how to check these? We have to expand the given equations. We have to expand it, and then we have to see whether it is in this form or not, or at least whether the degree is 2 or not of the variable. If the degree is 2, we will call it yes, it is a quadratic equation. Otherwise, no. Okay. Fine. How is the voice clarity? Clear? Okay. Okay. So the first one, x plus 1 square is equal to 2x minus 3. No? So what to do next? Imply sign. Since we are trying to simplify an equation, we are dealing with an equation, we have to put an imply sign. No? And then we have to go on simplifying it. At the last, we have to check whether it is in this form or not. Means the degree is 2 or not of the equation. Okay. Say next what? Take. Yes, I will remove the bracket on the right hand side. What to do on the left hand side? What it is? X plus 1 square, no? X plus 1 the whole square. So yes. So expand it. Tell me. Say. A square plus 2x 2 into a into b, that is 2x plus 1 square, that is 1. No? Yes. Is equal to 2x minus 6. Okay. And then what we will do? We will try to bring all this side. No. So x square plus 2x plus 1 minus 2x. No. Plus 6 is equal to 0. No. And now we will try to simplify. So minus 2x and plus 2x, what we will get? And plus 1 and plus 6. So it becomes x square plus 7 is equal to 0. So actually we do not have to right now find the value of x. It is not asking solve the equation. Is it asking solve the equation? No. It's just asking whether this can be called as a quadratic equation or not. This is the question. So what we did, we opened, we simplified, we tried to bring in the ax square plus bx plus c is equal to 0 form, and something we got like this. No? Now here, how to check whether the equation is quadratic or not? We will see the degree. Degree means the highest power of the variable present in that equation, okay, or the polynomial. So here it is an equation and the highest power of the variable is 2. So it is a, yes, since the degree of the equation is 2, so the above equation is a quadratic equation. Fine, done. Like that. Second one is also there like that. Third one is also there. Fourth, fifth, sixth, seventh till 8th. Okay, we have. Seventh one. Let us try seventh one. No? So seventh one. Yes. Which one? Seventh one. So seventh one is x plus 2. The whole cube is equal to okay. Now help me in simplifying it. A plus b whole cube. Here was a plus b the whole square is equal to a square plus 2ab plus b square, or you write a square plus b square plus 2ab, same thing. No, here we want a plus b the whole cube. The formula is, expansion is a cube plus b cube plus 3ab into a plus b. A cube plus b cube plus 3ab into a plus b. This when further expanded, most of the time it is written like this in this form. When it is further expanded, we get a cube plus b cube plus 3ab into a, 3a square b. Okay, and then plus sign 3ab into b, that is 3a b square. So a cube plus b cube plus 3a square b plus 3ab square. This is also, both are same only. So we'll try to expand this way. Come on. X cube plus 2 cube plus plus 3x square into 2 means 6x square. No, 3 2 the 6 and x square. No, 6x square. 6x square. No, 3x square 2 you told. No, 3x square 2. So all are in multiplication. No, 3 into x square into 2 means 3 to the 6x square. No, is it okay? So 6x square. No, plus 3ab square. 3x 2 square means 2 to the 4. 4 3 are 12. 12x. 12x. No, is equal to open the bracket. No, so what it will become? 2x cube minus 2x. Okay. So see, here we are getting what? X cube. No, from here only we can say, but later let us arrange it. No, so when this will go to that side, what will happen? 2x cube. When we will move to left hand side, what will happen? It is in plus right now, in addition on the right hand side. No, so when it will go to that side, it will go in subtraction. So x cube minus 2x cube, like terms will be added, subtracted. X cube minus 2x cube, how much? X cube minus 2x cube. 2x cube. 1x cube will come and the sign will be of the greater one. So great minus. So minus 1x cube means minus x cube. No, minus 1x cube means minus x cube. X square is only one term plus 6x square. No, then x term, there are two terms. Shift this that side. Minus 2x will become plus 2x this side. No, so 12x plus 2x, 14x. Now the constant 2 cube means plus 8. 2 to the 4, 4 to the 8. No, is equal to 0. Is it okay? So see what we are observing here, that no, this is not a quadratic equation. Why? Because the degree is 3 here. It is a cubic equation, not quadratic. Okay. So actually this question is not asking what type of equation it is asking whether it is quadratic or not. Just that much. So we will write since the degree is not 2. Okay. Since the degree is not 2, the equation is not quadratic. Okay, done. It is not asking what type of equation it is asking whether it is quadratic or not. So we will not bother about cubic or biquadratic. No, we will not write that. We will just say since the degree is not 2, the equation is not quadratic. Okay, this much. Fine, done. So the first one you can do easy. You will try all. Okay. Second one. See the second question. What it is asking in this? Represent. Read. Means in the word problem, some situation is given, and that situation has to be converted into quadratic form. Is it asking to solve that quadratic equation later? It is asking right now. No, it is not asking. It is only asking just convert the given situation into a quadratic form. Okay, mathematically you suppose something and then what you do, you try to convert into quadratic form. That much quadratic equation. Okay. Now read the question. Second question, the first one of exercise 4.1. The question is the area of a rectangular plot is 528 meter square. So okay, it is asking See what is given, the area of a rectangular plot. So something rectangular we have assumed on the right hand side, and the complete area means the region occupied by the enclosed figure. No, the region occupied by the enclosed figure, that is area. So this region is enclosed, occupied by this closed figure, and this is how much? 528 meter square. So since it is a rectangular plot, the longer length will be, side will be called as what, length, and then the shorter one is breadth. Okay, it is rectangle. Okay, don't go on this, all are 90 degree. Fine. So, and the condition is given that the length of the plot, this length, okay, in meters is one more than the twice its breadth. Whatever is its breadth, okay, make twice of that and increase 1 meter in that, you will get the length. So there is a relation between the length and the breadth is given in this question. Okay, the relation between the length and the breadth and the length is given. No, so from where we have to start? Do we have to start from length and move to breadth, or should we start from breadth and move to length? Given that the length, okay, given that the length is one more than twice its breadth, one more than twice its breadth. Length is one more than twice its breadth. This is the statement. No. This is the statement. Okay, so from where we should start? What we should start? First we should assume breadth, or we should assume length? If we will assume length, then from length we have to subtract 1. After subtracting 1, we have to make it half, then we will come to breadth. If we are assuming length, suppose length you told, no, L. So if we will assume, let L be the x. Okay, we have to assume first and then we have to substitute in that. No, so if we will assume length x meter, then what? Then from here we have to move 1, we have to subtract first, 1 meter first subtract. Okay, after that we have to go x minus 1 by 2. This will be the breadth according to the question. So in this breadth, twice will cancel this 2 and 1 increment will cancel this minus 1, and then we will get length. So is it the good way of assuming, or let us assume from breadth? If breadth be x, then according to the question, length is 1 more than twice its breadth. So make the breadth twice and increase 1 in that. This is the length. What do you say? Is it the good way, or is it the good way of assumption? From breadth it is the good way. Okay, it makes our work easier. We are not here with a fractional value, we are here with a fractional value. So whether this is a simple question, whether you assume this way, both will be easy. But later in some complex question, this is not the good way, this is not the preferred way. Okay, this one is the preferred way. Fine. So see, length is 1 more than twice its breadth. So first of all, we have to focus on twice its breadth. So to take twice its breadth, we have to assume something breadth. Let the breadth be x. Let the breadth be x. Then make twice of that breadth, 2x, and then increase 1 in that. 2x plus 1, we will get the length. Understood the relation? This we have studied in 8th like that. Okay, 8th and 7th. But still we have to see how to come to a given relation. Fine. So what we will write here? Let the breadth be x meters. We don't know how much. Fine. Then According to question, what will be length? Length, length L. What it will be? Let the breadth be x. Let the breadth be x. Then according to the question, what will be length? Yes, length is 1 more than twice its breadth. So 2x plus 1, okay? I need your concentration, full concentration, okay? Otherwise, problem. Okay, meters. Any problem? So according to the question, we have assumed a base as x meters and then length as 2x plus 1 meters. Why we did that? Why we assumed? To bring both length and breadth in one variable. To bring both length and breadth in one variable, we have assumed and we have brought according to the given relation the length and breadth in one variable, that is x. All are in x now. Understanding? Now why we need to bring in single variable? So that further we can go and come to a quadratic equation. How? See. Now according to the question, what is given? Let the breadth be x meter, then length. Okay, like this. Then length according to the question given. Okay, fine. Then according to the question, what is that? Area is equal to how much? 528 meter square. And what do we mean by area? Length into breadth is equal to 528. Okay. Yes, and according to the question, length is 2x plus 1 from our assumption, and breadth is x. So x multiplication is equal to 528. Okay. Now what to do? Multiply. Open the bracket. So 2x square plus x. No. So I am just trying to bring in the standard form. No. So 2x square plus x minus 528 is equal to 0. Okay. No. So what I have here finished? We have brought the given situation in the form of a quadratic equation with one of our assumption as the breadth x meters. Okay. Fine. Now if you will solve this quadratic equation, you will get the x value. How many values? 2x values. No. That will be called as roots of the equation. That will be called as, those will be called as roots of the equation, and the roots will what? So we will get two sets of answer or not? Suppose we got x as a and b, two roots. Since it is quadratic, two roots we will get. These roots may be equal, may not be equal. Okay. So what was our x? X was our breadth, no? So from this breadth, first and second breadth, no, we can get the respective length or not? Length 2x plus 1 we will get or not? So it will become what? 2a plus 1, or here 2b plus 1. If this is the breadth, this will be the length. This is the breadth, this will be the length. No. And if both are equal, then no problem. Then only one answer here also. Same thing. So actually we will get two set of answers. Two set of answers we will get, and both will be applicable according to this question. Okay. According to this condition, both will be applicable. Fine. So do not bother about this if you have not got this. Okay, we will further, when we will go to complex question, we will understand. Just for understanding little I gave this. Okay. So see the second question. Read it, no problem, read. Okay, so the product of two consecutive positive integers is 306. Okay, we need to find the so second question, second one, the product of two consecutive means just one after another. No alternate. Consecutive means 3, 4, 5, 6. What are these integers? So what actually integers are? Little integers means, yes, okay. And when we will study the real numbers, no, then we will go a little more in deep. So here the whole number along with the negative of the natural numbers complete constitute integers. No, so these are also integers fine. So consecutive integers means just one after another, 3, 4, 5, 6. All these are consecutive integers. Okay. So the question is that the product of two consecutive positive integers, and the condition is also given that they are positive also. So here we have taken positive neutron. And it is telling that the two consecutive positive integers product, like 4 into 5 is equal to, it's given 20, or 5 into 6, how much? 30. So in the question it is given like 20, 30 is given. So what is the question given? 3 not 6. No, some particular integer is there, and the product when multiplied together we are getting 306. So how we will assume that? If one positive integer we will assume be x, then what will be the another one? What will be? X plus 1. Why? Because see 4, 5. How to move 4 plus 1 is 5. So how can we write 5 in terms of 4? By adding 1. No? 4 plus 1. So just like that. And why we are doing this? Because we don't know the value and we have to assume both in single variable so that we can form a quadratic equation. Okay? If we will assume here one is x, one is y, then how we will form quadratic equation? It will be xy is equal to 306. You won't be able to understand. That's why we are not just taking y as y, we are taking y as x plus 1 in the same variable. Fine? So as to get our quadratic equation. Clear, no? See, this is quadratic equation we are reading, no? After we will read the linear equation in two variable, then we will have little confusion about it. Hey, which question to solve quadratic, which question to solve linear word problems, okay? So that's why I am just giving little here also to understand, okay? We will see there. Don't worry. So what you will assume? See, you can try, no? All these sums, easy sums. One will be x. Let one positive integer be x, then another positive integer be is equal to x plus 1, and then according to the question, x into x plus 1 is equal to 306, and then simplify it, x square plus 1 minus 306 is equal to 0, and we have brought this only is required, no? So let us not waste time in these simple questions. We have to move fast and see the third question. You will try this third. Row. So this is the age problem, no? Do you remember something we had studied in the age problem, that whenever we try to solve the age problem questions, no, age related questions problems, then what we do? We should first, in 90% case of this problem, we should first what? Present ages, no? We have to first bother about present ages, no? And then let this be the future, no? Future ages, and let this be the past. So from the present only we will see in the question whether a relation is given in the past or in the future. But first of all our work will be to come to the present condition, present age. After that only we have to move either to the future or the past, and then go and get a relation over here, or then go and get a relation over here, and then make an equation and solve. This is the way. Okay? What I told? Whenever we will face the age problem, better try to come to the present ages assumption. Okay, try to be on the present time. What would be the age? If nothing is given, we will assume, fine. And then what to do? According to the question, either we will go in future or we will go in past. And then whatever relation is given, either the past relation or the future ages relation, we will make that relation, we will assume, and we will get our question solved. Okay, so one question here: how can we move from present ages, future and past? Suppose we have the present age, how much? You have suppose 15 years. Okay, right now. So from 15, after 2 years, suppose we want to calculate future age. After 2 years, what will be your age? 15 plus 2, that is 17. No. So this is the way of finding future. And suppose 2 years before, 15 minus 2 years. So first of all, we have to focus on present age. Then from the present, either we have to go future or past according to the question. Okay, after getting the past or future age, we have to go to the relation to form a quadratic equation, or to get it solved by the linear whatever, in two variables. So in this question given that Rohan's mother is 26 years older than him. Okay, so there are two persons, no, Rohan and Rohan's mother. Rohan and Rohan's mother, fine. So Rohan's mother is 26 years older than him. Who is older? Rohan's mother, of course. How much older? 26 years older than him. No? So is this statement the present statement or not? Present condition statement? Right now, it's not about past or future. It's telling right now Rohan's mother is 26 years older than. So is this statement not talking about present ages? Yes, it is talking about present ages. So we will not have to bother, because we are in a present condition. We have to assume first present. So what we should assume? Rohan's mother's age we should assume, and then we have to go to Rohan's age, or Rohan's age assume, go to Rohan's mother's age. What we should assume? Rohan's mother's age, let us assume first. Okay, so it will be x. Suppose x. So x plus 26, if you are telling, then you are not assuming Rohan's mother's age. No, if Rohan's mother's age is x, then Rohan's age will be x minus 26. And that's why this is not the preferred assumption. Okay, this is not good. Again, what we should assume first? Rohan's age. Let the Rohan's present age be x years. Let the Rohan's present age be x years. Right now he is x years old. Then right now his mother's is x plus 26. No. So we assumed Rohan's age. We came to Rohan's mother's age, present ages, and these are the present ages. Okay, these are the present ages. Now see next statement: the product of their ages. The product of their ages in years 3 years from now. So is it talking about the present ages product? No. Is it talking about the present ages product? No, it is talking about the ages after 3 years. After 3 years, whatever their ages will be, the product of those ages is how much? 360. So isn't it talking about future relation, future age relation? So from here, that's what I only told. This is the present, first work done. No, second age, go to, according to the question, either go future or past. So here the future relation is given, future age relation. So tell me, from now 3 years, what will be the age of Rohan? After 3 years, what will be the age of Rohan? Present. Hey man, what is present age? X years. So x plus 3. X plus 3 years. And what will be his mother's age after this? X plus 26 plus 3. So it will be x plus 29. Understood? The second work done. Here the future work. Third what? Third work, get a relation. Third work, get a relation. So what is the relation given? That the product of which age? These two ages. The product of these two ages is equal to 360. So x plus into x plus 29 is equal to, and then simplify it, multiply. Okay, and simplify it, bring it in the form of x square plus bx plus c is equal to 0. In this form you bring standard form and then answer over for this question. Okay, easy, not tough. So whenever you face age problems, whenever, first try to assume the present ages. Okay, then you see the relation is given either of the future ages or the past ages. According to that, go in the future or the past ages and then find the relation according to the given statement. Fine. Questions will be so easy, the age problems, if you go like this. Okay. Next. Next question. Read next question. Okay, so go silently and think what to do. Okay, go through it silently and think what to do. Get an approach. Yes, Mithun. The current is gone. Okay, so what you can do, little you can increase the brightness. Okay, if it is okay, then no problem, or else little you can increase the brightness. Fine. Okay, think and just tell me what to think. Okay, x kilometer per hour. Okay, tell me is the second statement. Okay, let me read this question. See, a train travels a distance of 480 kilometer. This is the distance, 480 kilometer. Okay, and a train is traveling a distance of 480 kilometer at a uniform speed. Uniform speed, do you understand what is uniform speed? Constant speed. Constant speed. If it is going with 60 km per hour continuously till the whole journey, it is going with 60 km per hour only. Okay, uniform speed, constant speed. Now in the whole journey it is going 60 km per hour, means every hour it is covering the same distance, 60 km. The next hour also 60 km, the third hour also 60 km, fourth hour also 60 km. So what is that speed? Not given. No, not given. I am telling just example. Okay, that that if it is covering 60 km per hour, suppose if it is running. Okay, now what is the question here? See, a train travels a distance of 480 km. Fine, this is the distance the train is traveling. If the speed had been 8 km per hour less, if the speed had been, what is it given? What does it mean? Some speed was there, some original speed was there, okay, and then the condition is being applied on that original speed, means the journey has already finished with some speed, with some particular speed of the train, journey is already finished, understanding, and then somebody is applying the condition that if the speed had been 8 km per hour less, means with whatever speed the train finished its journey, okay, if that speed had been less, how much, 8 km per hour, had been 8 km per hour lesser, then it would have taken 3 hours more to cover the same distance. Means if originally it had taken some hours, then in this case the train would have taken 3 hours more, 3 hours extra. So from the second statement we are understanding that something actually already has happened, finished, done, okay, and this second statement is actually the condition. No, second statement is condition, that if this thing would have happened, something would have happened, like that it is given. No. So from these two, one actual and one conditional statement is given. Actual statement is hidden. That is we are getting clear view of the actual statement from the hidden statement. Understanding? So from these two statements, what we have to do? We have to try to solve this equation. Okay. So tell me what we should do. What we should have assumed. If the speed had been let the speed of the train be 8 km per hour. No, x km per hour. No. What is speed? Original or this conditional speed? Original speed. Okay. So let the speed of the train be how much? X kilometer per hour. No. So next what? Say. And what is the total distance given? Here, total distance. km, okay, and let the original speed be this. So therefore original time, can you calculate original time? Time means how much time it took originally to complete its journey, how much time it will come. From the distance and from the assumed speed, how much time it will come. Time is equal to, we have a formula, distance is equal to what? This is a basic formula, distance is equal to speed into time. So we have the two things. Whenever we have any two things, the third we can find using this relation. No. So the distance is given. Speed we have assumed. Can we